Welcome to solverfy.
This question asks us to draw the MO diagrams for a couple of different diatomic molecules. So to start, we're going to do a diatomic molecule of beryllium, and then we're going to look at two of the different ion forms. So I went ahead and drew out the atomic orbital diagrams for beryllium by themselves. And you can see since there's 4 electrons, we're going to have a filled 1s and a filled 2s. And then from this, based on MO theory, we can go ahead and just start filling into the lowest molecular orbital first. So we would have 1, 2, 3, 4, 5, 6, 7, 8. And so that would be our MO diagram for BE2. And so now we can look at BE2 plus. So that means we're going to have a cation, so we're going to lose an electron. And we can lose an electron from either side. It doesn't really matter. So I'm just going to go ahead and erase one there. And since we erased one over there, we would have to erase an electron from our highest atomic orbital. And so this would be BE2 plus because we're down an electron. Alternatively, we could go up an electron. So we'll add this guy back. And we'll go ahead and put another electron up there. And then we would have to, so that's added back, and then we would take that electron and go ahead and put it into the pi orbital. So this would be our electron configuration for BE2 minus, because we have that extra electron. So now we can go ahead and look at our second part, which would be the diatomic molecule boron, so B2. So B2, boron has 5 electrons, so we would have to go ahead and draw in our 5 electrons on either side of the atomic orbital, and then we can go ahead and add up our electrons. So we already have 8 in our image right here, so we have to add 2 more. And we would go ahead and fill across before we would pair our electrons. And so this would be our MO diagram for B2. And then if we lost an electron, we would just erase those like that, and that would be B2 plus. And then if we gained an electron, we would add one there, and we would have this. So those are all of our MO energy diagrams, and it shows our electron configuration for the MO orbitals of those series of diatomic compounds.